Hello everyone and welcome to another video. My name is Agnes and the topic of today's lesson is definition and nomenclature of inorganic acids. Acids are chemical compounds consisting of hydrogen cations and anions are the acid residue. The general formula for acids can be written as HMA. M number of hydrogen atoms equal to the valency of the acid residue. A acid residue, aerobic or anaerobic. What will the acid formula look like in the end? It all depends on A, so on the acid residue. The acid residue may either be a single atom, for example, chlorine, bromine or sulfur, or a group of atoms containing amount over oxygen. A is important because A generates or dictates the number of hydrogen atoms in the acid molecules. Because if, for example, A is divalent, there will be 2 hydrogens. And if it is trivalent, there will be 3 hydrogens. Our magic A determines the structure and properties of a given acid. I think we can safely say that A, the acid residue, is the boss here. How to correctly name these acids and what to name their acid residues? Let's name each of them. Let's start from nomenclature, anaerobic, oxygen-free acids. Our first acid, HF. The name of this acid is formed by adding the prefix hydro, then there is the name of the element of the central atom of this acid, fluor. At the end, we add the suffix IC. The acid residue of this acid is F-. When we create the name of this anion, we write down the name of the element and add the suffix -ide. The second acid, HCl, again, we start its name with the prefix hydro, then the name of the central atom, and at the end of the name we write down the suffix IC. Next, HBr has the same rule for creating the name of the acid and the anion of the acid residue. HI, same story, same rule. And finally, H2C. Now let's focus on the nomenclature of oxyacids. Our first oxyacid, H2CO4. The name of an oxyacid is created by starting with the name of the element that is the central atom and then adding the suffix IC. HNO3, same rule. H3PO4, same story. H2CO3, same rule. HClO4. In this case, the name of this acid begins with the prefix per. This happens because chlorine forms several oxyacids. Some elements that are central atoms form different acids depending on their oxidation state. For higher oxidation states, the rules that have already been explained for oxyacids apply. In the case of acids in which the central atom is in a lower oxidation state, the rules are as follows. The beginning on the acid name is the same as for the central atoms in higher oxidation states, but we add the suffix -os at the end. Note, we also change the suffix in the name of the anion of the acid residue. Okay, let's look at the examples. H2CO4 and H2CO3. The higher oxidation state of sulfur is sulfuric acid. The lower oxidation state of sulfur is sulfurous acid. Let's see the second example. HNO3 and HNO2. The higher oxidation state of nitrogen is nitric acid. The lower oxidation state of nitrogen is nitrous acid. And one more example. HClO4 and HClO. Again, the same suffix rule for the higher and lower oxidation state of the central atom of these acids respectively. Guys, that's all for today. If you like this video, please leave a thumbs up and subscribe to be notified about the next videos. I also invite you to leave comments. Thank you so much for your attention and see you in the next video.